Hey friends, so I'm back here after some weeks, and it was later than usual. Took more time. I was actually testing some ideas I had in Minecraft because it's the cheaper. I already have the game, so I can just construct things. And now I'm gonna explain how I'm trying to build a 8-bit computer in Minecraft. I tried to use the idea of the SRAMs from the registers from the real computers directly here, but like so much bigger than the user, right? So here is the way I designed it. I will explain everything. So it's basically the idea of the memory one that we have here. Let's see. Hmm. We can we can keep here for now. But basically the signal will come from here and we'll write inside the register. The register would be the whole the whole structure, but it is the main part. So every time you actually turns on or off, it will turn this side on or this side on. If this side is on, it's off. So it's basically it reads only one side. So we can write 1 or 0 here, and I'm reading from below here. So if it is up, I interpret as one. It's if it's not, I interpret I 0. And there is also this line here that I put a lever here, is the word line. We can actually pretty easily imagine how it works. If we go here, this is the post I wrote about memory. Let's see, where is the draw? It's basically this. So we can just see exactly as the side on and the side off is the exactly same working as this, but we can also visualize in the real drawing here where we have the word line here, which is the one that actually give the permission to write some data there. Here is like two inverters. It's the same, but it's at transistor level. It's important to say that in Minecraft I didn't use any transistor because the lever would be a transistor, but it's hard to work on. But at the same time, it's really easy to make inverters because of this property of putting sign on from here, and the torch here will be turned off if and only if I put it here, the torch turns off. So it it will just change the system here. This is the on signal, right? So it is the higher level, like the VDD in the original memory situation up. But you can see that the signal isn't changing, and you can ask me why, and it's exactly the function of the word line that permits writing. So every time we need to write something, it turns off the word line, and here we wrote the 0 signal, then we actually deactivate the word line again. And now doesn't matter what type of noise comes from here. We already wrote the 0, right? So this is 1 bit, and I did 16, like 2 registers of 8 bits. I connected everything here, like uh, 2 from each layer and duplicates for the side. So you can see, I can put here, there is 2 here, 2 here, 2 below, and 2 below. The writing line would be this one, that when comes to here turns invert the signal, this turn on the signal. I did the word line passing below and then come back from the backside to here. We can see word lines come from here, come from upside here, here, and also there. And it's unified somewhere here. Mhm. So it unifies there. This line is the word line that actually creates a branch and turns on and off the other registers upside. And we have a way to actually save the data. And here I constructed it in other just to realize some to do some summations, some sums actually with the two bits. The first actually not two bits. There's two numbers of 8 bits. The output is also 8 bits, which is a problem because it should be 9 in the worst case scenario. But I didn't do the error bits that should exist there. So here it's all the signals that's coming from each layer. Each layer process each bit basically. I didn't parallelize anything, but it's possible. Also, the memory is really, really, really possible to optimize, and in the performance, in the building, in the size it occupy. We also could output from above and input from below would be easier to. So back here, basically you have two register, one other, and there is the is a way to subtract numbers. You write the numbers here. So you write the first number here, the second number here, and here I didn't connect it yet because it's a lot of time involved, and I think it's a better way. I will talk about this later, but I didn't connect it yet. So you write the first number here, the second number here, the output would be here. Here we do the subtraction, and the other side we do the addition. And this line is basically a mess because this one basically writes to the first register, this one writes to the second registers. The output or the read line that I said it goes below from for each register. The below part basically is the data it's writing. So it, it writes from upside and reads from below. So it goes to the adder. It's already directly connected to the adder, and also do the addition. It comes back. It was coming back here, so we could already see the output. It was working, everything fine. So it is really cool. But I actually tried to rewrite this in the first register because this way we can actually aggregate some operators later. For example, you have the A and B, you sum both, writes the result in the A, then you can do new operations with the value in B, or you can write another value in B and do the operations, the aggregation value. So this I think is the best case scenario. But as I said, it's kind of a mess because the cables, it's a bit too much. But I will talk in a minute about that. I will show the clock I'm doing here because a good way to implement a better way of this is here. So in the next part, the next moment I enter the Minecraft, I will try to do this. The central unit, you can just input the first value, the second value, and specify the type of operation. I will also do the multiplier and the divisor, but it's, it's a bit mm, it's a bit tiring to do. And the multiplier and the divisor specifically is a bit boring too because it's basically the adder and the divisor with just some chains. The divisor, actually, the subtractor is just a minor difference from the adder. You just have to put some two knots. I don't think I will have. This is the adder. Is XOR gate, AND gate, OR gate, XOR gate. Right. The subtractor is the same, but it has these two knots. Um, so this is the only difference. The whole structure is basically the same too. The first layer is a bit different, but I'm not gonna talk about that right now. So I think in doing these shared lines because it would be easier to manipulate the data. And here is the word line. I will trigger the word line before this one because it will be active for more time. So here I put one more repeater in Minecraft because you can just delay the signal with the repeater because the tick will be mm, like late. So with that, you just start the word line, you write the data, then you start to do the next operations. And here, instead of the adder or the subtractor, would be ALU, which can do any type of mathematics or arithmetic operations, which would also write the data again in the register A. Maybe I will do 3 register just to be easier, and everything will be manipulated with timing. And for timing, I will use the clock. Sorry for the other cut, but just recapitulating. This is the clock. I put a lot of swords here because the sword occupies like a stack block because it's done stacks. The comparator is looking for the chest, and the chest just activates the redstone based on how filled the chest is. So each clock, which the observer here will be looking for the redstone and will be actually looping. So let me show how it goes. You put here, and the signal starts to just flip around, and in each flip it will send an item to the chest. Important to say that I will have to change the charge because the chest now the items are coming inside the chest, and each headstone signal upside the hopper will block the hopper. So I have to keep the signal on, and the cheek have to be deactivated hopper. So this will be the clock, and why I have to do the clocks, which is the cool part here, is basically you want the clock to manipulate everything and be sure nothing will broke. For example, if it takes 2 ticks to come to the register A, the clock will activate the next signal only on after these 2 ticks actually triggers. So just okay. Here is a way to block the actual. Wait a second. Here, this is a good way to block the data from passing. I just put a lot of comparators. I click the comparator, and when I deactivate with the T station, the comparator will not let the redstone signal pass to the lines. So you can just start controlling these blocks to only what you want to happen actually happen, which here would be, for example, block this one and write to the register A, and write to the register 2. These two would be synchronized. Then you stop the word line, which is the red one. Then everything goes to the ALU. And we also would pass directly from the central units the type of operator, for example, if you're summing, subtracting, or even other type of operation. Doesn't really matter. And here will also be with the clock. The ALU will be async, will, will not be synchronized with the whole system, but the clock will only do other operators after the ALU result comes back to the register A, and the central link detects this part, which will be another headstone signal. So basically everything will be synced in some way. Yeah, I know I just say the ALU will not be synced, but basically everything else is synced. But right now, I think I spent 35 or 40 hours in this map because I tried to design it from scratch. I didn't get anything from the internet besides the redstone because I never did anything with redstone, and this one was a good challenge. So this will be all for the Minecraft part. I will as I said, I will come back here later and try to implement that. Also, I want to do some assembly instructions and also a ROM part, which would be st- mm, like a writing, never rewriting part of processing, basically for synchronizate everything. So this will be done later. Right now, I'm uh, writing again about the CNNs and neural networks, just so I don't get too tired with Minecraft and these computer parts. But it was a lot of fun till now. I know when I come back it will be easier because it will be less less of this mess passing everywhere. It will just be harder to manipulate everything and synchronize. But instead, that said, that's all. I will post about CNNs in the next weeks. I don't know when this video will be out, but today is 14/7, so maybe tomorrow. And that's all. The CNN parts, I don't know when it's gonna be launched, but I think this week too.